Hi, Profs. My name is Salahuddin Tansir Ahmed, and on behalf of Team P43, welcome to Scott Jones Medical. So, most teams set out to build a standard e commerce website. We set out to answer a different question: what does a real multi clinic medical platform actually need to get right? So, our solution was a zero build front end, AI assisted triage, and enterprise grade infrastructure. I'll be walking you through what every user sees before they even log in, the public facing portal. Before I show you the live site, I want to quickly address the design language we chose. So we call it Neo-Swiss Brutalism. It draws from Swiss International typographic style and combines it with Brutalist web design principles. The result is a site that feels clinical, precise, and trustworthy, which is exactly the tone you want for a medical platform. So concretely, this means high contrast black and white as base palette with a sharp red accent, zero border radius on every card, button, and container, and system font typography. So since we're not importing a custom font, this keeps the page load fast. So moving on to the live demo. So here's the landing page. On desktop, you're seeing a 2 to 3 column grid. So let me shrink this down to mobile view. So on mobile view, everything free flows into a single column, so there's no horizontal scroll or no cutoff text. Nothing breaks, so every section, card, and button adapts accordingly. So that's the Bootstrap's responsive grid. So we tested it across Chrome, Firefox, Edge at mobile, tablet, and desktop breakpoints. And the navigation bar collapses into a hamburger menu in the top right hand corner. So when I tap that, the full nav slides out cleanly and every link is there and still tappable in the same logical order. So, and on top of that, we ran all of our color combination passes the WCAG 4.5:1 contrast ratio minimum, and we ran the whole website through the Wave Accessibility Checker and got zero contrast errors. Moving on to the specialist directory. So this is the specialist directory. The cards are laid out in a responsive grid, 3 columns on desktop, 2 on tablet, and 1 on mobile. So each card shows the doctor's name, specialty, and clinic branch, and a book button. The cards maintain equal height within each row regardless of content length. That's the CSS flexbox, keeping the layout visually consistent. So there's the specialty and search drop-down, search name field. So if I were to click cardiology, it gets filtered out. So we get instant results. So there's no page reload or no spinner. This is the client-side JavaScript filtering. The PHP controller pre-renders all the specialist data into the page, and our JavaScript filter filters the visible cards in real time by reading the specialty attribute on each element. So the button, book appointment button, is full width within each card. So on mobile, it's easier to tap with the thumb. So the touch target exceeds the WCAG minimum of 44 by 44 pixels. Hover over a card and you'll see the border highlight. So this is a visual affordance that doesn't rely on color alone. It works for colorblind users as well. So moving on to the clinic map. So the clinic location browser is powered by the Google Maps JavaScript API. The card list on the left and the map on the right are linked in both directions. So if I were to hover over a clinic card, its map marker bounces, giving the user an immediate spatial sense of where the clinic is without having to scan the whole map. And if I were to click a marker, it automatically scrolls down to the matching clinic card. The cards show the full address, opening hours, and available specialties, everything a user needs to make a decision. So if the map API ever fails to load, these cards display all the information as plain text so that the page never breaks without it. With that, I'll pass the time over to Isa. Thank you.
Hi Professor, my name is Isa and I'll be walking you through the authentication and security features of Scott Jones Medical. Let's start at the registration page. Notice our password requirements: minimum 8 characters, 1 uppercase, 1 number, and 1 special character. Let me test the password which is invalid. Notice the form won't even submit as we have client-side validation. Now let me create a test account with a valid password. As you can see, registration is successful. Let me log in. After login, I'm in the patient dashboard. Our session is stored in the MySQL database, not server files, powered by Zebra Session, making our application nodes stateless. Now let me demonstrate password reset for the existing account. I'll enter an email that doesn't exist. See how the website shows the same thing for if an account exists, a password reset link has been sent. It doesn't say an email is not found. This prevents user enumeration. During development, we use Mailpit to catch these emails. Let me open it. Here's the email with the secure token, but let me show you what happens if someone tries to use an expired link. Here, it shows that the token is invalid or expired. Now let me request a new link. And here, I can enter my email address to get a new link. Now let me reset the password. So here, you can see that I can reset the new password. And now my password has been successfully resetted. Now let me demonstrate server-side validation. I'll use CURL to try login as a doctor with an incorrect password. The server returns the login page, not the dashboard. Even bypassing the front end, the server rejected the temp, proving authentication happens server-side. For XSS protection, we use HTML special characters and a custom sanitizer service that strips malicious scripts while preserving safe HTML. This secure foundation allows Boon Heen to demonstrate the patient booking engine. I'll now hand over to Boon Heen.
Hello, Professor. My name is Boon Heen, and I'm going to walk you through how the patient would book their appointments. Okay. So let me log in to one of the users. Okay, so now we are in. So let's try to book a new consultation. Okay, so I choose this doctor right here. Okay, so for reason for visit, let's just try general consultation. And of course, what happens, if you want to book a time slot from the past? Okay, so as you can see, you can't book a time slot from the past. Okay, as you can see, it's reactive, and it will be locked out. And before it's visible. Okay, so it really cannot select it. Okay, so what if we want to book an appointment on the Sunday itself? So as you know, our clinic is closed on the Sunday. So as you can see, it's grayed out as no interaction is possible as it enforces both on the front end as well as the back end. Okay, so now let me have two users. Okay, so here we have two users. So this is Jin H and this is John Doe. Okay, so let's make a appointment. Okay, let's select the same doctor. Let's try this 144. This 8 o'clock. 30 for booking. So as you can see, once a user has booked their account, the other user won't be able to book the account on the same day, same time. So as you can see, this is concurrent protection. We're working with the database level using the select for update, preventing any double bookings under the high traffic. Okay, so next, so as you can see now, I'm not using full screen. Okay, I'm responsiveness using smaller size screen. So as you can see, okay, for example, we want to reschedule. You no longer see the big calendar view, but a smaller one. So as you can see, you can. Let's try, for example, we will try to book an appointment on the 3rd. Okay, so as you can see, you'll be able to do so the same. Okay. So next, okay, let me go back to my dashboard. Okay, so let's say, if I want to, reschedule, okay, so you want to book, let's say on this, it must always be 24 hours, in advance before you want to book, you want to reschedule your appointment. Okay, so let's say, okay, let's go back. You want to cancel the appointment. Okay, so this one, same thing, must be able to cancel 24 hours in advance. Let's take something way before. So as you can see, once you cancel the appointment, you'll be able to see the logs cancelled on the past and cancel. So with that, I've come to the end of my demo, and I'll pass my time over to the next speaker. Thank you.
Good morning, professors. I'm Jakey, and now I'll be demonstrating about the doctor dashboard. So first, let me log into the doctor's account. Okay, so as you can see here, this is the doctor's dashboard view. Over here, you can see some patients which have their appointments booked for this doctor. And yeah, so you can see the month view, the week view, and as well as the day view. So you can also click on the individual appointment and look at the details like the reason for visit and notes if the patient has provided any. So you can click on the all day here to book leave, or you can also click on like you can select multiple dates just by clicking and dragging to book a block leave. So right now I'll try to book leave on the day where I have an appointment, like at the doctor. So as you can see here, the system will prompt that active appointments exist in this range, so I will not be able to book the leave. Now I'll try to book block leave on days where I do not have appointments. So the dashboard has updated with my new leave booking. And now I'll try to cancel an appointment for a patient. And my dashboard has updated that the appointment has been cancelled successfully. So moving on, we have this appointment analytics, which shows the type of consultations that the patients have booked this doctor for. So this is powered by Chart.js. And yeah, it basically showcases it summarizes the number and types of appointment inside a chart. Yeah. So moving on, I'll be going to manage showing off the blog post. So here, I'll try to write a new post. So once I publish the post on the blog page, you can see that there is a new post being published, like today. And I will now showcase the deletion of the post. So the post has disappeared when I refresh the blog page. Now I'll be trying to perform our XSS attack on the blog post through the content. I'll be pasting in some malicious HTML code like iframe. So once I refresh the blog page, you can see that the iframe was stripped through with our custom sanitizer service, and only the bold text remains. So that is it for me. I'll be passing on to the next person. Thank you.
Alright, hi, I'm Joseph, and I'll be taking over how we handle patient data portability and compliance. So earlier on, Issa logged in with his test credentials and he created a test account, right? So I will also log into the same account. And I'll also be using his same password as well. So after we have successfully logged in, I will click on my profile. And I'll update my allergies to peanuts. So currently this test profile has no past medical history. Let me add that in. Save my changes and export. We can see that he has his past medical history of peanuts. Under appointment history, we can also view both past and future appointments. However, this test account doesn't have any. So the reason why we have this is because we want patients to always have immediate access to their complete formatted medical dossier. Next, we also address GDPR compliance with our account deletion process in danger zone. Instead of performing a hard delete that will break our relational integrity of our database, we anonymize the data. So let me demonstrate this directly in the database. So firstly, I'll have to SSH into the cloud server first. And once inside, I'll execute the command to see the accounts of deleted patients, where we can see deleted patients, their deleted emails, which are anonymized and randomized, as well as password hash, which is completely empty. So next is our AI symptom matcher. We integrated the Gemini 3 Flash model using the Google Gemini PHP client library, but more importantly, we strictly enforce a JSON schema. This guarantees that the AI always returns structured, predictable data that our system can reliably parse. Let's try a live demo. I'll input sharp chest pain and numb left arm. As we find our specialists, notice how it instantly processes this, recommends the cardiology specialty, and even reports the exact token usage of the request. When I click Browse Cardiology Specialist, it immediately redirects to the specialist directory and also filters for the required specialty doctor. So moving on to our architecture, I designed our frontend to be entirely buildless. This means we have absolutely zero Node.js dependencies in production. By leveraging native ES modules and pop maps, we achieve a React-like component structure using Preact and HTML libraries. Behind the scenes, everything runs on a robust Docker stack. Moving to the terminal, running Docker Compose PS shows our isolated containers working in harmony. For our CI/CD pipeline, I'll be demonstrating this via our GitHub. Where we can see past and prior token runs. So pushing to the main branch automatically builds our images, pushes them to the Google Artifact registry, and securely triggers an SSH deployment to our Google Compute Engine instances. Finally, let's discuss our architectural trade-offs. So firstly, we prioritize development velocity and modularity over a monolithic approach. By enforcing a strict one-feature file policy for controllers and views, we can work on our functional domains. So this reduces the git merge conflicts. Secondly, we engineered stateless app nodes using the Zebra session library. Instead of relying on our local PHP sessions are persisted directly into our MySQL database. To demonstrate that, I will view the contents of the session data table, and we can view both the session ID, hash, as well as the session expiry dates. In conclusion, we haven't fulfilled our module's requirements for a data-driven PHP and MySQL application. We've engineered a high-stakes clinical portal that prioritizes security, accessibility, and modern performance. We have created a responsive WCAG compliant experience that balances a bold neo-Swiss aesthetics with rigorous technical standards. This project stands as a testament to how our engineering and discipline can transform a standard assignment into a production-grade medical platform. Thank you.